Hello and welcome to our Team 2 Phase 2 final video presentation. The team members included throughout this video include Raphael, Tejas, Jericho, Richard, Omar, and myself, Noor. To begin, we're going to show you a little demo of how our synthesizer works, showcasing its pitches and its ability to reach 2 octaves. The first step in our prototyping process was deciding what type of synthesizer to create. Uh, After numerous discussions, we actually agreed on a light-dependent synthesizer because it seemed to be the most novel out of everything. After that, we had to then design a working concept, and we had to make a circuit comprising of transistors, capacitors, batteries, and this took lots of trial and error and research on our part in order to properly implement an oscillating transistor. And after the working circuit was created, we then had to make it more user-friendly. At this point, it was just a bunch of wires connected to a speaker, and we didn't want the user to then have to prick their fingers and combine all the different circuits in order to make it work in the first place. So we designed a very simple box to put the wiring and devices inside of, and we also implemented LED lights inside to act as a source of sound for the resistor. Depending on the lights, when they would change the intensity, it would then create a different note. More light would create a higher pitch, while less light would create a lower pitch. And we also decided to include a dial knob, which when accessing different pitches, the 6 pitches that we already have included, you could then change the frequency of that one pitch, allowing for different octaves to be reached.
Hey guys, so our testing assessment process, we wanted to determine whether or not the synthesizer met the constraints of the project. So the first thing we wanted to determine was how many decibels the synthesizer was producing. So we placed the decibel meter about 5 feet away from the synthesizer, and it produced approximately 80 to 90 decibels consistently. After that, we wanted to see how many notes and octaves the synthesizer was producing. So we had a tuner and we went through all the dials and notes that the synthesizer was able to produce, and we were able to meet the requirement of 2 octaves. Last thing we wanted to determine was how long the battery of the synthesizer would last. So obviously, the user would need to replace the synthesizer's battery. So we determined around 3 days of average use was how long the synthesizer would last, which is a pretty good amount for only 2 12-volt batteries.
The final stages of the assessment process mainly involved determining how an individual could use the instrument and how it could look. To facilitate this, we had to design a body for the instrument which would make it easy to play and carry around. Hence, we went with a simple laser-cut acrylic box. To allow for greater sound, we had to now use a larger speaker compared to the ones we used in our prototypes. Now, we considered many sources of light, such as bulbs, flashlights, but we ended up using a simple LED strip that could be wrapped around the inside of the box. We implemented a brightness level switch and a rotary dial, which can allow one to use the instrument by adjusting the brightness levels and using the dial to modify the sound produced at each brightness level. After this, we decided the box had a nice Christmas theme going for it with the lighting of the box. So we slapped a snowman on it.
All right, so here's our previously implemented ideas. First, we tried soldering our wires together, but they kept breaking up due to our lack of experience with soldering. Secondly, we tried doing a 3D printed box for our case, but it's a lot harder to work with. So we just went with a laser cutted box. Next is we made a separate circuit for the light source, so the current for the LED and synthesizer is independent from each other. Another idea we tried to implement is the use of potentiometer in the light circuit, but it burned out due to the excessive current in the circuit. And lastly, we tried to use 2 speakers, thinking that it would be louder, but it resulted in the same decibels as using 1 speaker.
How would this be built by other people? To implement this questionnaire of the box idea or our synthesizer of basically with this statement, make a box synthesizer that can make sound through a speaker. So what other people or like what other general society would think would be to use different resistors. But with that, it would be producing a fixed sound besides an alternating sound, like what we did with the light dependent resistor. That it could be a 3D printed box instead of laser cutted, but a 3D printed box would take a lot more time than getting it laser cutted. Using a transparent plastic box to eliminate the need for an internal light source. And with that, you can use a phone flashlight. But at the same time, you would be using the natural light from outside or inside a building for whatever environment you're in. The use of a light bulb, but that would further implement a hole in the box. And but that would be, something you would use instead of LEDs. But they're basically saying that it would be cheaper and just connect that to a potentiometer. And the potentiometer could also be used for LEDs. And but with our previous implementation, that was something that did not work.
So in conclusion, with this instrument that we've created, we were able to meet all of the required criteria, which consisted of being able to be played while wearing a mask. Its normal playing volume is greater than 70 decibels. The total cost is less than $60 to make the instrument, and the instrument will remain in tune for greater than 15 minutes. But not only did we create an instrument that met all of the criteria, but we also created an extremely unique instrument, not only in the way it looks, but also in the way that it's played and the way that it sounds. So I think that we were able to very successfully encapsulate what was being done in this project and what the goal of this project was.